NASA has dozens of robotic spacecraft exploring our solar system and beyond. Scientists and engineers communicate with and navigate faraway spacecraft using the Deep Space Network, NASA's international collection of giant radio antennas used to communicate with spacecraft at the Moon and beyond. But the Deep Space Network, or DSN, is more than just a messaging service. In fact, scientists use the DSN to perform radio and gravity science experiments. But what is radio and gravity science, and how can it help us learn more about the planets, moons, and other small bodies in our solar system? We're all familiar with gravity. It's the force by which an object attracts other objects, such as a planet pulling a spacecraft toward it. Gravity is also the force that keeps all of the planets in orbit around the Sun. Here on Earth, we experience this every day. If you drop an object, it will accelerate toward the ground because Earth's gravity causes it to fall faster and faster, and the acceleration of a spacecraft toward a planet depends on the mass of the planet. Less mass means less gravitational pull. These properties of gravity, combined with our understanding of radio waves, help us use gravity to study other planetary bodies in our solar system. After reaching its destination, a spacecraft uses radio antennas to communicate with the Deep Space Network on Earth, which in turn transmits radio signals back to the spacecraft. Every spacecraft travels in a predetermined path, emitting radio signals as it orbits around its target. Scientists and engineers can infer the spacecraft's location and how fast it's going by measuring changes in the spacecraft's radio signal frequency. This is made possible by the Doppler effect, the same phenomenon that causes a siren to sound different as it travels towards and away from you. The Doppler phenomenon is observed here when the spacecraft and the DSN antenna move in relation to each other. Differences between the frequency of radio signals sent by the spacecraft as it orbits and signals received on Earth give us details about the gravitational field of a planetary body. For example, if the gravity is slightly stronger, the spacecraft will accelerate slightly more. If gravity is slightly weaker, the spacecraft will accelerate slightly less. By developing a model of the planetary body's gravitational field, which can be mapped as a gravitational shape, scientists and researchers can deduce information about its internal structure, all while using the Deep Space Network. To learn more about the Deep Space Network, visit go.nasa.gov/about-DSN.